What is the difference between a public IP address and a private IP address? And why do we have certain ranges of private IP address set up to make this work? Well, I'm going to go down the simplistics of this, but I wanted to talk about where this came from so that you got a kind of a foundation here. The Internet Assigned Numbers Authority, the IANA, reserves the following IP address blocks for use as private IP addresses, and you're going to understand that in just a few seconds. The 10.0.0.0 all the way to 10.255.255.255, 172.16 all the way to 172.31.255, 192.168 all the way to 192.168.255.255. Those are the three ranges of private IP addresses that can be used. Why do we use private IP addresses? This question is asked on every test, so here it goes. I'm just going to give you the basics of why we have private IP addresses and why we have public IP addresses. Let's say we've got a number of networks here. Some of these are corporate networks. Some of them are mid-sized businesses or small to mid-sized businesses. One or two of these might be a small home network with just your router and a laptop and a phone connected or something along that line. Whatever their size is, you are going to have multiple private networks here. And they are considered private networks because you don't want someone from the internet or from someone from the other side of the planet being able to hack into your network. So you want to keep these private. You don't want people knowing what the IP addresses are of every single device on your network. We'll also get more into the NAT, or Network Address Translation, and PAT, Private Address Translation. We're going to get into that later on. And that does come into play here when we're dealing with private and public IP addresses. But this video is just to give you the simple explanation of it. Each of these networks is its own private network. And that's hence why we need a private set or private range of IP addresses that we can use inside of our own networks that nobody else on the internet or the World Wide Web or anybody else in the world knows about or can find out. So let's say this first top right one is a corporate network. We're going to use the 10.10.00 all the way to 10.10.200.255 range simply because we've determined that we are a corporation and we've got that many devices that we have on our single overall network, and we need to be able to use that many IP addresses. So that's why we're choosing the 10.10 range or the 10.0 range of private IP addresses. Okay. The next one over might be a very small office network. You might just have, say, 10 people working there, but you only need to use the 192.168 range because that provides you enough IP addresses inside your little network to hand out to every device on your private network. So that's why you would choose a 192 range. Let's say this other one over here is a slightly larger network, but they still got enough IPs in the 192.168 range that they can go ahead and use those, have their firewall or router or DHCP server hand those out inside their private network there. This one might be a home network. You just have a router and two devices connected, so you determine that the range of IP addresses private that you want to use is 192.168.2.0 to 192.168.2.50. And let's say you're handing out 50 IP addresses there. Now let's say this network here, this private network, is a small to mid-sized business and they need a slightly larger number of IP addresses than the 192.168 can provide. They're going to choose to use the 172.16 set of private IP addresses inside their network, have their router hand those out because that provides them enough growth, but they don't need to go the size of, say, a corporate network. And then let's say this last one down here on the bottom left-hand side is a large corporate network, and they need to utilize every IP address within the total range of private IPs on their own network. Okay, that's all said and good. That's why we have a range of private IP addresses that we can utilize inside our networks. This way, this also helps us to we can have the same IP address, say in the top left-hand side network, corporate network, as we have on a device on this bottom left-hand side corporate network. Neither of the two networks can actually see each other than their outward-facing IP address, and I'm going to get to that in just a second. So they can have devices that all use the same IP address. It doesn't matter because they're all inside a private network. Then we have the internet. The internet is considered the public range. The worldwide network is considered the public range of IP addresses. And we're going to get into this shortly, but as we had more and more devices that were connected here, and really what I'm going to do is I'm going to give you an idea of how this kind of went down. You might have had an ISP that was handing out the public-facing IP addresses for these two companies, and they were given a certain range of IP addresses to hand out to their customer base or their clients. You may have another one over here, another ISP over here. They were handing out a certain range of IP addresses they are allowed to hand out. All of these IPv4 IP addresses that each of these ISPs across the planet started to hand out began to start using up the available IP addresses inside the public domain. And the reason they began to do that is because in these set of public IP addresses, using IP version 4, there were only 32 bits in an IP address that you could utilize. And this only originally provided, which they thought would be plenty, but they weren't sure, provided 4,294,967,296 address combinations of public IP version 4 addresses that could be used. Now, as you can only imagine, what happened was, using IPv4 on the public domain like this, those addresses began to be used up quickly, especially when we started getting mobile devices and everybody had 3 to 5 different devices that they utilized on a regular basis, and you can only see how that would chew up this number really fast. So, to resolve that, and I'm not going to get too much into the detail of it now, we went to IP version 6. Now this is now IP version 6 is a 128-bit number in size. So it contains this large number of IP addresses that can be handed out if you're using IP version 6. So if we run out of public-facing IP version 4 addresses, we can simply start using IP version 6. Now, last I estimated and last I heard, we could almost assign an IP version 6 number to every single particle on planet Earth and still have some left over. I'm not sure if that is actually scientifically the case, but you get the idea. IP version 6 allows plenty of public IP addresses that can be used, and we can all still utilize our private IP addresses on our private networks. So that's basically the rundown of it. If you want to see what your own public IP address is, not your IP address inside your private network, but that your router gave you or your DHCP gave you, if you really want to see what your public IP address is, the easiest way to do it is to go to Google and say, what is my IP address? Or what is my IP? You can also go straight to this website, which may show up in your search results. When you run that in Google, you can just go to whatismyip.com and it will immediately pull up what your public IP address actually is. And that can usually be seen right around in here. It will also tell you if an IP version 6 is detected or being used and where it thinks your location is. Okay?